how to use a definite integral to find the area of a region bounded by the two curves. So for our two formulas, we have x squared plus 2 and y equals negative x. And for the intervals, we have 0 to 1. And right here is the drawing. The f of x is x plus 2, which is the parabola up there. And g of x is this straight line right there. And so from the graph, you could see that the parabola was on top, so you put that first, so it's x squared plus 2, and then you subtract the one on bottom, which was the negative x. So, and then you do the calculation for that, and then you get x squared plus 2 plus 1, and then the integral is from 1 to 0, because that is the interval on the graph in which the area is from. So now that you have this equation, you now take the antiderivative of it. So you would add 1, and then you put that over 1, and then you end up getting 1/3 x cubed. And then you do that for the x, so then you'll get x squared plus 2. And then you do it for the 2, and you get 2x for that. And then the numbers stay the same because there is no change in variable. So now you plug in 1 and 0. So when you plug in 1 for the x, you get 1/3 plus 1/2 plus 2. And then you plug in 0, and it all becomes 0. So then now you get 1/3 plus 1/2 plus 2. And in the end, you get 17/6.
Okay, so here are equations: y equals x squared plus 2x plus 1, and this is the second equation, 2x plus 5. These are intervals, and this is the graph right here, and we're finding the area between the two graphs. Okay, so f of x equals 2x plus 5, and g of x equals x squared plus 2x plus 1. So this is how we would set it up, because you would put f of x first because it's the top one, and then you would put g of x second because it's the bottom one. Okay, so from the graph before, 2x plus 5 was on top, and the parabola x squared plus 2x was on bottom. So you would put 2x plus 5 first, and x squared plus 2x plus 1 on bottom, the second one. So you combine the two equations, and you get negative x squared plus 4. And then you find the integral of that, and you get negative 1/3 x to the third plus 4x. So then you would plug these two into the equation, so you would get negative 8/3 plus 8 minus 8/3 minus 8, and in the end you would get negative 16/3.
1. So for the problem today, we're going to be finding the volume of the area of the graph's root sine x and the x-axis between the intervals from 0 to pi. So for the basic formula, volume is pi, the integral of b of a rx squared d of x. So for our problem, rx represents sine x from the intervals from pi to 0 dx. So now you take root sine x squared, which gives you sine, and then you take the integration of that, which gives you negative cosine x. And then from your intervals from pi to 0, you plug in those two, and so you get pi parentheses 1 plus 1, which gives you 2 pi. So now for our final problem for volume, we have find the volume of a solid formed by the revolving the region bounded by the f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. So as we go to the graph, you can see this is the 1, this is your 2 minus x squared, and then that's the area that the volume we're trying to find revolving. So now going to the formula, we take f of x minus g of x. So when combining those two equations, we get 1 minus x squared. So now going to the generic volume formula, you get pi, the integral of a and b, which is 1 and negative 1, times the equation 1 minus x squared d of x, and now we do,
and then from here,
so then you get 1 minus 2 of x, 2 squared plus x to the 4th d of x. So now we take the integration of that equation, and you get x minus 2/3 x to the 3rd power plus 1/5 x to the 5th power. And then your interval is still 1 to negative 1. So after you do all that work, your final answer is 16 over 15 pi.